In this video, I'm going to teach you lesson 5.4, which is solving radical equations and inequalities. So for this lesson, we're going to talk about how you solve an equation when it has a radical or when it has rational exponents, and then also follow the same ideas with a radical inequality. So first thing we're going to start with is some vocabulary. So if you look at page 140 of your student journal, we've got two terms that we need to look at. So first of all is a radical equation, which exactly is what it sounds like. So it's an equation that has a variable under the radical. And then we also have what's called extraneous solutions. And what that means is we'll go through and solve these and find some answers, but we have to make sure we check them that they work in the original equation, because sometimes the answer that we get will not work. So an answer that can't be included because it does not work in the original equation is called an extraneous solution. So how we will solve these is the first thing you need to do is isolate the radical on one side of the equation if necessary. So you want to try to get whatever your radical is all by itself. So take off anything that's multiplied to it, anything that's added to it. And then we're going to raise each side of the equation to the same exponent to eliminate the radical and to get the other, basically what you want to solve. And then you're going to solve using what you did in previous chapters. So it's equation solving steps that we did with Algebra 1. And then you need to make sure you check your answers when you do this. All right, let's start with number 2. So we're on page 141. I'm going to do this with you on the student journal. So go ahead and take notes with me. So first thing we have on here is number 2. It says solve the equation, check your solutions. So when I look at number 2 on here, we want to try to get the radical by itself. But if I look at this, it's already all by itself. I have it so that way I have the third root all by itself already. So if I want to try to get whatever's under this radical out, I have to apply the inverse to both sides. So if this is a third root or a cubed root, we're going to cube both sides of the equation to help us get our answer. When you type this in, so negative 4 to the third power, you're going to use parenthesis negative 4, and then use the caret button, which is right here under clear, and then raise it to the third. So that will give me negative 64. So negative 64 is what it equals. And then on this side, the reason that we cubed it is those two things are inverses, so they're going to cross each other out, and we'll have whatever we have left over underneath. So 5x plus 1. So if I've got 5x plus 1 equals negative 64, we have to solve for x. The best thing you could probably do is put a little box around your variable, because that's what I have to deal with last. So first thing we want to do to solve this would be subtract 1 from both sides. So 5x equals negative 65. And then we're going to divide both sides by 5. So x equals negative 65 divided by 5, negative 13. But here's where we have to check for the extraneous solutions. So once I get x equals negative 13, I have to make sure this works, because if it doesn't work, then I have to call this no solution. So I'm going to take my original equation and I'm going to plug in negative 13. So third root of 5 times negative 13 plus 1, and that has to equal negative 4 for this to work out. So if we want to check and see if that works, the best thing I can suggest you do is to simplify this as much as you can before you start doing your calculator. There's a lot of little things you have to be careful of when you type this in, so just use that, be careful. So first thing, start with multiplying this. So we're going to take 5 times negative 13 plus 1, and that gives us the third root of negative 64. So now we want to know, okay, is that true? So we're going to take our calculator, and you're going to go to, you're going to hit 3, hit the math button, which is down here, and then you can choose the number 5 every time, no matter what your index is. If you wanted to, you could also use this to get the third root, but it doesn't work in every case, because obviously they're not all going to be cubed roots. So we're going to use number 5, and then we're going to type in our negative 64 that was underneath. And if we type that in, we get negative 4. So this is true. So that means my answer is negative 13. So make sure you check your answers. All right, let's go ahead and try number 3. So here's number 3. We first need to try to get the radical alone, because right now it's not alone. It's stuck in there. So to solve this, it's very similar to what we would do if we solved something like this in Algebra 1. Same idea. We're going to try to add or subtract first. So we're going to add or subtract. In this case, subtract. Move the 6 over to the other side. So that will give us 4 equals 1/4, and then the 4th root of 2x. And that's still under our radical. So now we need to try to get the radical alone still, but we have 1/4 times this. So to get rid of the 1/4 times this, we have to multiply both sides by the reciprocal, or 4 over 1, or just 4. Once we do that, these are going to cross out, and we're going to end up with the 4th root of 2x equals 16. Now we're really close, but we're not quite there yet. So if it's the 4th root, to get rid of the radical now, we're going to take both sides and raise them to the 4th power. So we're going to put a little 4 up there. So if I do that, these are going to cross out because they're inverses. And we'll have 2x equals 16 to the 4th, so a really big number. So 16 to the 4th power, and then again, use that caret button so you can type it in, is 65,536. And then last step to find x is divide by 2. Divide by 2. So we end up with 32,768. But we don't know if this is the right answer yet. We have to check it and make sure it's not an extraneous solution. So we're going to put a little check mark. Let's try to figure this out. 1/4, the 4th root, and we're not going to do number 4, so you can keep going over here. The 4th root of 2 times 32,768. And then be careful, the 6 is on the outside. And we want to make sure, does that equal 10? So now, first thing, try to simplify this as much as you can. So if I multiply these two things, we're going to get 1/4, the 4th root of 65536, because we did that earlier on. And we want to make sure this is true. So one other thing that might help you when you type this in, if it's 1/4, we know 1/4 is 0.25. So we're going to use that as well. So if we want to type this, we're going to take 0.25 and then do parenthesis, 4, math, x with the root on it, because this is the 4th root. That makes this little 4 go in for the index. And then 65536. And then we need to close the parentheses because that 6 is not in the inside part of our radical. It's on the outside. So we're going to take plus 6 and then hit enter. And then we do get 10. So this is true. 10 equals 10. So this is our final answer. But don't be fooled. There are some that do have extraneous solutions. All right, let's look at number 5. So number 5, again, we're not going to do 6. So if you want to use the whole room, you can. First job when we solve these is try to get the radical alone. So if I look at this, the radical is already by itself. So I need to go through and try to get rid of this now. So if there's no little number right here, there's no index, this is a square root. So to get rid of it, we have to square on both sides. And then this uses a lot of the stuff from Algebra 2A, some of the concepts that we learned. But if we do that, these are going to cross out because they're inverses. But now we've got x minus 7 squared equals x minus 5. Be careful here. X minus 7 squared means we're going to take x minus 7 and times it by x minus 7. So before, when we've done this, we made a box. So let's go ahead and make a little box. We're going to take x minus 7 and multiply it by x minus 7. So in here, we're going to do x times x is x squared. Negative 7 times x is negative 7x. Then another negative 7x and 49. Once we fill that in, we need to combine like terms. So we usually look on the diagonals. That's typically where they're located. If I combine those together, we've got x squared minus 14x plus 49, and it still equals x minus 5. And then what I'm noticing on here is this looks like a trinomial, which is something we used to do with factoring. So we're going to end up having to factor on this one as well. So to do that, we're going to move everything to the other side. So subtract our x, add our 5. Gotta make it equal to 0 before we can factor. So now it's x squared minus 15x plus 54 equals 0. And then we're getting close, but we still got to factor. So when we factor, this is the X box method that we do. What's nice about this is our A value is 1, so we don't need a box. So you're going to do A times C on the top and then B on the bottom. So A times C is 54, and my B value is negative 15. So we need two numbers and multiply to 54 and add to negative 15. So that would have to be 9 and 6. But that doesn't quite work yet because we have to add it to be a negative 15. So both of these have to be negative. Then to help you solve, we're going to do x minus 9 times x minus 6 equals 0. And if we solve those, you basically get the opposite of both. So x equals 9, x equals 6. But we don't know if either of these are going to be actual solutions. We have to check them. So if we want to check them, these are actually easier to do if you do them like by hand, not using your calculator. So we're going to do, take 9, plug it in for x. So 9 minus 7 equals square root of 9 minus 5. Possibly, we have to solve this. So if we solve that, we've got 9 minus 7 is 2. 9 minus 5 is square root of 4. And the square root of 4 is 2. So this is one of my answers. And then we're going to do the same thing with 6. So 6 minus 7 from our original equation equals square root of 6 minus 5. So now if I do this, 6 minus 7 is negative 1. 6 minus 5 is 1. And then we got to think about it. Okay, square root of 1 is positive 1. So this one will not work. So this is an example of an extraneous solution. So you would have to cross it off, not include it in your actual answers. All right. Let's look at number 8. So number 8 has two radicals in it on one side. So in order to actually get rid of the radicals, we do need to move them so that way they're one on each side. So first thing we'll do is kind of like what you normally do when you solve equations. You're going to move something over to the other side. So we're going to add 3 times the square root of x plus 1 to the other part of the equation. So it looks like this. And it's going to look like square root of 2x plus 2 equals 3 square root x plus 1. Now, even though it's kind of weird because there's a 3 still attached, one of my radicals is alone. So we can go through and square on both sides now. So we can get rid of that square root. And if we square it, this is going to cancel out and this is going to cancel out. So we've got 2x plus 2. But be careful over here. 3 times the square root of x plus 1 squared means I have to take 3 and square it. So that's 9. And then if I square root or take something that's square root and square it, it's going to give me whatever's left over underneath. So we have to multiply those two. So that's going to turn into some distributing that we have to work through. So now what we're going to do is distribute 9, multiply it to both pieces. So 2x plus 2 equals 9x plus 9. Move our 2x to the other side. So 2 equals 7x plus 9. Minus our 7 from both sides. So negative 7 equals 7x. And then divide by 7. X is negative 1. Double check that it works okay. So plug in negative 1. So we've got, if we check it, 2 times negative 1 plus 2. And then subtracting 3 times negative 1 plus 1. And does it equal 0? So we're trying to figure out. So if we simplify this by hand first, it makes your life way easier. You're going to multiply these numbers. So 2 times negative 1 is negative 2. Negative 2 plus 2 is 0. So square root of 0. This one is negative 3 times negative 1 plus 1, another 0. And then we want to know, does that equal 0? So square root of 0 is 0. Negative 3 times 0 is 0. And then we get 0 equals 0. So this is our final answer. So this is what it looks like when we have a radical to start. Now we're going to look at what happens if we have a rational exponent. So a little bit different. Let me adjust my camera so you can see okay. We're going to look at number 11. So here's number 11. This refers back to some of the concept we learned on the first day, so from 5.1. So if you want to use that as a reference, you can use that as well. But first thing we need to do is we need to try to get this x to the 5/2 all by itself. So to get that alone, we've got 1/2 times it. We're going to multiply both sides by 2. So we multiply both sides by 2. These are opposites, so we can cross those out. And we've got x to the 5/2 equals 32. Once we do that, we can rewrite this into a form that we know how to actually solve. So we can rewrite this into radical form. And this is the flower power root as the group rule that we talked about on the first day. So when we do this, we're going to write a radical, take your base, so your x, and rewrite that. And then your flower, or the number on the top, becomes the power that's underneath the radical. And then the root, or the bottom of the fraction, becomes the group size. So that's going to be your 2 that goes there. Then we still have 32. So now if we want to solve this, we've got a square root all by itself. So we can square on both sides. 32 squared will give us 1,024. And then we still have x to the 5th left over. So this one's kind of crazy. But now that you have the x to the 5th left, we're going to take the 5th root on both sides. So we can get rid of the x to the 5th. So if we take the 5th root of 1,024, we're going to type it in as 5 math, x with the root on it, and then 1,024. So you got 4. And then double check that it works. These are a little easier to check because you can type them directly in. So if we do 1/2, 4, and then we want to raise it to the 5/2, make sure you put parentheses around that, and make sure that equals 16. So we type it like this. So 1/2, and then 4 to the, and then 5 divided by 2. Looks like this, 16. So that one worked. Woohoo! So those are all equations. The last thing we have to cover is the inequalities, so the ones that are down here. We're going to be looking at number 13. What's nice about these is the solving steps are the same. The only thing that's different is the ending. So if I want to solve this, and this were like an equal sign instead of r greater than or equal to, we're going to try to get the radical alone first. So same first step. We're going to move the 3 to the other side. So we've got greater than or equal to -4. And then over here, we've got -4 times the square root of x minus 1. If I want to simplify this, I still have to get the radical alone because it's not there yet. So we have to divide both sides by -4. Here's one of the little things you have to be careful of when you solve with inequalities, is if you multiply or divide by a negative, you have to make sure you flip the sign to make sure it's still true. So you have to flip it so it goes the other direction. And then we still have x minus 1, and then this is a 1. So now if I want to solve this, my radical's all alone. I can finally square it. Now if I square it, we're going to have x minus 1 is less than or equal to 1. And then we have to add our 1 to the other side. So x is less than or equal to 2. So that is our solution set so far. But the only problem is when we do inequalities, we have to be careful for the answers that will give us complex, because we only want our answers here to be real. So what we need to do is called find the domain restrictions. So to find the domain restrictions, we're going to take whatever's underneath our radical, so only that piece, and we need to make sure that we don't get a complex number. So that I value that we have. So we're going to take the x minus 1, and we want to make sure all of the values that come out from that are greater than or equal to 0, because we don't want any negatives. So we're going to start with this, and then to solve it, we're going to add 1 to the other side. And then that changes what our answer is going to look like, because we need to make sure it's bigger than 1, and then it also has to include this piece over here. So what we need to do is create a compound inequality. What might help you visualize this is to draw a little number line. So 0, 1, 2. if I want to graph this inequality, because it has this equal sign underneath, that means a closed circle. And then if I drew a little arrow, so if this is an arrowhead, it's pointing to the left. So we're going to draw an arrow that goes that direction. Then we can do the same thing with this one. There is a dot at 1, and then we can point our arrow to the right. And we need to represent what this little section right here is, that overlap, because that's where our answers for this are going to be located. So to write that down, what we're going to do is create a compound inequality. So to create a compound inequality, we're going to take the number that's smaller, so the 1, write that first, an x in the middle, and then a 2 on the end. And we need to make sure our inequality signs face the right directions. So on 1, we can see that our inequality sign is facing the x, so it's like eating the x. So we want to make sure when we write it here, it's still eating the x. Same idea with 2. This one's facing the 2, so we need to make sure over here that it's facing the same direction. This second part's going to be basically a copy job of what you did in the beginning. And then here's your final answer. All right, let's do last one. One more to practice, because this one's kind of weird. So for 15, we're going to start by trying to get the radical all alone. So to do that, we're going to add 39 to the other side first. And if we take negative 25 plus 39, we end up with 14. And then we still have 2 times 3/4 x in the square root. Now, radical's still not alone, so we still can't square. We have to divide both sides by 2. So if I divide both sides by 2, this gives me 7. And then less than or equal to, and we still have this radical over here. Now what you'll have to do is try to get the radical to disappear. So we're going to square it on both sides to get our variable all alone. So if I square it on both sides, I've got 3/4 x is less than or equal to 49. To simplify this, we need to make sure the x is all alone. We're going to multiply both sides by the reciprocal, or the flipped over fraction that's next to that x. But the kind of tricky thing with this is going to end up being a decimal. But if we write these as fractions, it makes it a lot easier, especially when you do your big idea homework. So if we want to type that in, we're going to take 49, and we need to times that by 4 divided by 3. So we type it like this. And this is what we get for our decimal. But like I said, don't do decimals. You want to make sure it's still exact. So to change this into a fraction, you're going to hit the math button and then hit enter, enter. And that will give you the fraction that you want to use. So x is less than or equal to 196/3. Now, because we have an inequality sign, we have to do our domain restriction again. So my domain restriction is going to be making sure that any of the values under my radical have to be bigger or equal to 0. So we're going to take our 3/4 x, because that's what's under the radical, and that has to be greater than or equal to 0. So if I want to solve this, I need to multiply both sides by 4/3. And then these will cross out, so x has to be greater than or equal to 0. Now we need to create our compound inequality again, comparing both of the pieces. If we make our number line again, we've got 0 and then our 65.3 basically from our fraction. This one has a closed circle, and it has to face this direction. And then this one has a closed circle and has to face the other direction. Our solution is the overlap. So we need to create our equation. For our equation, we're going to start with the smaller number, so 0, put x in the middle, and then we have 196/3. Make sure that your inequality sign is facing the x for the 0, and then facing the 196/3. And then that's your final answer. So the number line piece is making sure that you are including exactly what you need from the solution set. And then that's the end of lesson 5.4. So go ahead and start working on the big ideas homework. Great job.